In this video, we're going to be looking at Mod 2, Lesson 4, which is solving exponential equations and also evaluating our non-common logs. So for this, our big thing is we're going to look at how to solve an exponential equation when it's in base E or base 10, and then also how do we evaluate logs that aren't in E and 10. So our steps that we saw way back in the first lesson, we didn't use it, but it was just kind of good to see. We're going to isolate the base, take the log base B of each side, and solve for x. So the first couple problems, we're going to be using our common bases, right? Or basic base. So when we look at this, we have 10 to the x is equal to 92. So like we saw in the previous video, if I have a log equation, the inverse is raising it to that base. The inverse of when you have that base as an exponential equation, you're going to take the log of each side. This is log base 10, so I don't actually have to write the little 10 if I don't want to, since both sides is base 10. So I'm going to take the log of each side. It's always best to use a parenthesis if you're able to, so you don't make any little mistakes. And my answer to this equation is the log of 92. And if I put that in my calculator, I'm going to get 1.96, right? And again, what that means is if I put 10 to the 1.96 in my calculator, I would get back 92. So that's our solution to that equation. For the next problem, same idea. So I'm first going to isolate my base, which is 10 to the x. And to do that, we're going to go ahead and subtract 4. I'm going to divide by 2. And I always like to leave a little space, knowing that I'm going to end up doing a log there. And now I'm going to do the log of each side. So I have a log of 35, log of 10x, that gives us an x. And so in our calculator, you would do the log of 35, and our final answer for that would be 1.54. For question 3 and 4, it's the same concept, but we're actually using the natural log. So same idea. I'm going to get my e to the x by itself. So we're going to go ahead and add 7 to both sides. Divide by 4. And I'm going to leave it, it's just a fraction for now, but you don't have to leave it as a fraction. You can make it a decimal. And then we're going to take the natural log of each side. So again, the natural log is the inverse of e. And so in our calculator, we can actually just type in the natural log button with a parenthesis, put 29 over 4, close it, and that would give us our final answer. So we can let our calculator and the display function do a lot of the heavy lifting. And our final answer would be x is 1.98. And then finally for our last one, same thing, we're going to isolate the base, which is e. I'm going to leave myself a little space here. And I'm going to take now the natural log of each side and use a parenthesis. And the parentheses is going to be really helpful here because if I want to solve for x, I'm going to subtract from both sides, but it's not going to touch that 22. I have to evaluate 22, the natural log of 22, and then subtract 1. In our calculator, your calculator display function can handle you putting all that in if it's a TI-84 or any Texas Instrument calculator. And if you use a parenthesis, it's gonna read it correctly for you and tell you the answer is 2.09. The second part of this lesson is something called the base change formula. So basically in our calculator can only do base 10 in the natural log or base e. So what happens when we have something like, let's say example 1, where it's the log of 64 base 16, right? Where it's something that's not a 10 or an e. So what we're going to do with our base change formula is we have to type it in our calculator as 2 logs. So in our calculator, we would type the log of 64, so the log of 64 base 10, basically, and we're going to divide it by the log of 16. And again, that's not the same as 64 divided by 16 and doing the log of 4. You have to really do the log of each part. So you can do a few different things here. You can do the log of 64, parenthesis, log of 16, parenthesis. If you're not confident you're doing it right, you can even do a big parenthesis in your calculator first and then put it all in there. And then when we go ahead and evaluate, we're going to get our final answer. In this case, it would be 1.5. So what that means is the log of 16, or the log of 64 base 16 is 1.5. Or like if I was to rewrite it, 16 to the 1.5 is going to give you 64. For this next example, the rest of them, same thing. You're going to be using the base change formula if it's not to base 10 or E. So this first one, we do have to do the base change formula. So again, that's using our base 10, or you can use the natural log, but usually base 10 is a little easier because we kind of remember to do that more. So the log of 1/16, and we'll do a parenthesis over the log of 8. And again, if you're not confident, you can put it in a big parenthesis too. And when you evaluate, you're going to get negative 1.33. For example 3, or problem 3, same thing. If I want to evaluate and get what number this is, I have to use the base change formula. So log of 2 over log of 5. And when we divide, we're going to get our answer of 0.43. And so the top two, we had to use our base change formula. For the bottom 3, we don't have to use the base change formula because they're bases that we already know are common bases, right? So this is E and the natural log, and this one's 10. So you don't always have to use the base change. The top 2, you just had to. So since this is base 10, we could do base change, but our calculator can do base 10. So we would get 2.47. And we put that all in our calculator. For number 5, when I did the natural log of 13, we'd get 2.56. And then the last one, when we do the log of negative 12, you should get a no solution. So you can't have negatives or 0 being evaluated by a log. If you have any questions, you can sign up for T-Bolt time, get help in the center, or ask questions during class.